Hi everyone. So in this math video, we're going to talk about the origin of complex numbers. So how did we come up with complex numbers from the traditional number line? Okay, that will be the first part of the lesson. In the second part of the lesson, I'm going to show you how to draw complex numbers on an organ diagram. That will be the second section. And in the third section of the video, we're going to check or learn how to calculate the length of a complex number. And I'm going to show you the formula and I also show you how the formula was derived from something you already know, which is the Pythagoras theorem. All right. So I'm going to share the whiteboard with you so that we can start discussing about complex numbers, which is very powerful as a technique. All right. So let's just go. So first of all, you need to understand how it's written, okay? So a complex number is written as Z, and we always use the letter Z to denote a complex number, okay? So it's denoted by Z, and it's written as A plus BI, where A is the real part of the complex number, and B is the imaginary part of the complex number, okay? Now, what do these two things mean? Okay, real and imaginary, okay. Let us look at that. So you are used to a number line where we have positive numbers here, all right, and you have negative numbers, okay? So I have -1, I have -2. But what happens with complex numbers is you have another dimension. So we have this axis which you're used to, it's still called the real axis. But now we have another axis which is called the imaginary axis, which is perpendicular to the real axis. All right. So numbers don't really exist just as real numbers. They exist as points here, possibly. Okay, so this is a number Z1. Okay. So this is actually a complex number Z1 consisting of a real part, because it's 2, and then an imaginary component. So let's say that's 2 here also. So this will be 2 plus 2i, because the B component, which is the imaginary component, that's 2. Let's say I take a complex number. Okay, let's say we put it here, and this is 3. Okay. So this will be written as -2 plus 3i. And this complex number, we're going to call it Z2. So Z2 is -2 plus 3i, and it's located here. And in that way, you can actually locate a complex number anyway. Let's say I have a complex number here. This will be, we're going to call it, let's say Z3. So Z3 will be 1, because it moved 1 unit on the real axis, 1, and then plus 2i. So you see, that's what complex numbers is about. It's actually about dealing with numbers in 2 dimensions, all right? So you've actually learned how to locate complex numbers with that introduction we just did. So let's say we have Z equals 2 plus 3i, okay? And I draw 2 units on the real axis. So it's good practice to write that as real Z and to label this axis as imaginary Z, okay? So I'm moving 2 units on the real axis, 2, and then I'm moving 1, 2, 3. I'm moving 3 units on the imaginary axis. So this is my complex number Z, all right? And this is where it is, and that full thing, I mean, that diagram with the 2 axes, real and imaginary, this is called an organ diagram. Okay, it's written like that, organ, A-R-G-A-N-D. Okay, organ diagram. Okay, so if you're asked to draw an organ diagram, they're actually looking for that, okay? The complex number and what's the reference, okay? What's the real component and what's the imaginary component? Now, you see this complex number, okay, we can actually find the length of this complex number. All right. And how can we find the length? If you look at it carefully at what I'm doing right now, I'm making you realize that it's actually a right angled triangle. And we move 2 units here, so the length is 2, and we move 3 units up, so the length is 3. But this is a right angled triangle. If you want to find the length of that complex number, it's actually the hypotenuse of that right angled triangle. And if you try to recall your IGCSE, hypotenuse to the square is opposite to the square plus adjacent to the square. So h square is opposite. So if that's the angle here, theta, opposite is 3. So 3 square plus the adjacent, which is 2, 2 square. So h square is 9 plus 4. And h is square root of 9 plus 4, which is root of 13. So the length of the complex number is root of 13. And that's it. That's how we find the length of a complex number. So here I've shown you how to derive it, the length of the complex number, but you can actually learn it as a formula. So in general, if r is a plus bi, all right, the modulus of r, which is the distance, is root of a squared plus b squared. So you don't need to draw and actually show you're using Pythagoras theorem every time you need to find the length. You can just use that formula. So what I'm going to do now is, since I've shown you the derivation, I'm going to show you how we just work it out directly. So let's say I have z equals 1 plus 5i, and I want to find the distance of the complex number. So modulus of z will be square root of 1 square plus 5 square. You'll notice that I'm putting bracket even if both numbers are positive. That's because in case you had negative numbers, using the bracket will be helpful. So that's 1 plus 25, and this is root of 26. So it's root of 26 units, okay? Let's try to do one where we have a negative component. So z equals minus 2 plus 5i. Okay, this one is interesting. So modulus of z will be square root of, you see now it becomes important, minus 2 square plus 5 square. So root of minus 2 square is 4 and 5 square is 25. So you get root of 29, you see? So imagine you didn't put the minus here, it was out. You could have written root of minus 4 plus 25, which will give you a different result. You're going to get root of root of 21, which is not good. So this is why I actually used the bracket, okay? So this is how we find the modulus of complex numbers, all right? And that's it. So that's how you find the modulus of a complex number. So what we've basically done is I've explained to you where it comes from, okay, what's the origin of complex numbers, about having a number line and having a second dimension to it. And we've talked about how to draw a complex number on an Algol diagram. So you need to have a real axis, you need to have an imaginary axis, and then you locate the point there. Okay, it's like coordinates, nothing fancy, nothing difficult there. And once you've drawn the complex number, to find the length, we use Pythagoras theorem, but you don't need to show you're using Pythagoras theorem the whole time. What you can do is you just use the formula like I've shown you in the video, all right? So in the next video, we're going to look at the angles the complex number forms with the positive x-axis. And this is called the argument. So we're going to discuss that in the next video, okay? So I hope that you really find it interesting and it really doesn't scare you to learn complex numbers, okay? If you have a very good intro to the topic and you really understand the essence of it, everything becomes smooth, okay? So I'll leave you on that note, all right? So I'll see you very soon for